I will make myself a little bit comfortable here so you can easily see what we're going to present you today. So, welcome to the meetup. And today I would like to share a story with you that really inspired me when I first joined the company. So throughout the presentation, I will use one of the core components that we have, and I'll talk about how our service grew, how the load patterns changed through time, what issues we faced, and how we actually solved them. So I hope that some of you will find useful examples for your future endeavors, but perhaps you already solved similar issues so we can exchange our experience with each other here. All right, a few words about me. So I'm Alex. And tomorrow is going to be my first anniversary at Manychat in the backend lead role. And in overall, I have like 10 plus years of experience in software engineering, mostly on the backend side. And before we dive deep into the technical evolution of our system, I would like to provide some context on the actual product. So as Anna said, Manychat is the leading chat marketing platform, and businesses use it to automate their conversation with customers and perform marketing, sales, and support. And here's how the product looks like from the business customer side. So it's just an interface of Instagram application. And you see that Meta company provides businesses the ability to send various interactive elements to their customers to drive the engagement and to make the conversation easy to follow. So you may see on the slide like buttons, images, galleries, links, and many others. And here is actually the heart of our system, the component so-called flow builder. So business representatives use this tool to create their communication flows and scenarios by using like no-code programming interface. And this is just an example of one dialog that starts with, when user comments on your post or reel, send the message in response, thanks for commenting, then ask for email, then when email is provided, apply some tag to it, otherwise just start the delay in one day and then send a follow-up. So the flow builders allows maximum flexibility in programming these scenarios, which later on may cause a huge and a massive load to the company's infrastructure. And for simplicity, I'm going to use two terms throughout this presentation, bots and subscribers. With bot, we will call the entire collection of automations of one single business. And the business client who participates in the dialogue will be called a subscriber. This term is actually historically used by Meta just because a subscriber needs to kind of subscribe to the bot to be able to interact with it. And with that said, this is how the overall scheme of interaction with Meta looks like. So a customer performs some actions through a WhatsApp application, Instagram, Facebook Messenger, and then Meta company sends a webhook with this data to Manychat. Then Manychat processes the webhook, identifies what should be the response message, let's say, to the subscriber, and then sends back to a customer through a send API. And businesses over here, they just use web or mobile application to configure the business logic of this bot. So in overall, pretty straightforward. And this is an example of a single webhook. So it's just a JSON payload that contains some information about what action happened between the recipient ID and the sender ID. So overall, the webhook processing is one of the core components that we have right now, just because it enables the communication between business and their customers. And if this communication slows down or fails completely, then businesses just simply lose value, which is not acceptable at all. And I would use this webhook processing component just as an example to illustrate how a service architecture evolved through time. Okay, and to handle all of this, we use a relatively complex tech stack. So at its core, we have PHP plus Nginx, PostgreSQL as our database, then Redis, Elasticsearch, and everything runs on the Amazon Web Services. So let's go back in time and start our story. 2016, May, we've just released our service and there are 20 bots on the platform, 10 of them actually created by ourselves, the test bots, and the average RPS that we experience is around 0. At the very beginning, there was only a Facebook Messenger and the only support of the automation of the direct messages in the Facebook Messenger. And the architecture looked this way. So the webhook request is handled by Nginx, then it's transferred to PHPSrbija, which loads our YE application, and then the webhook control PHP is just a single file that actually processes the business logic and sends a request to Meta API with a response to the subscriber. Again, pretty straightforward. 1 month after we announced our service at Product Hunt and acquired first 2K new users. This time we actually faced the first issue. So Meta send API is not that fast. Let's say not that fast at all. Some of the requests may take seconds. And if we need to send like a couple of messages for one webhook, then the handling of the webhook would take even dozens of seconds. On the other hand, Meta expects our service to respond quickly under milliseconds. And if not, Meta just stops sending webhooks to the Manychat app and eventually kind of block it. This is actually how their policy works. And to be able to comply with this policy, the easiest solution that saved us was to close the connection and instantly respond with 200 code once the request passes like initial validation here. And in the meantime, in the background, we are still able to perform the actual business logic and process the response to subscriber. So let's move on. How a year passed. The audience increased 10 times, and now the system experienced the average load around 500 RPS. And in the meantime, we released a couple of new features. First, the live chat component was created. It allowed businesses to send messages through the Manychat web application. So literally just write a message through the Manychat, and then it's going to be sent to the customer. And second, we started to aggregate and showcase the statistics over the messages, whether they were delivered and then opened and read. So it means that we started to handle 4 different webhooks instead of just 1. And at this moment, there were only 2 backend engineers in the company, and they didn't really want to overcomplicate the architecture. And that's why they used a simple approach and just separated webhooks processing into different streams. So the one with the actual message, it goes directly to the webhook processor, while the rest of them that are kind of tolerant to some delay, which is read, deliver, and echo, messages that are used for the statistics, they could be stored in the separate database and then kind of processed at their own pace. Well, the next milestone, the audience grew again, so 2017. And previously we were dealing only with the webhooks from the direct messages, but at this time we also implemented a new feature. We gave an opportunity to react to and communicate with the subscribers in the post feed. And here you may imagine like how many posts marketers usually do to engage with their audience. Then they count each new like, react to it, comment to it. So this gradually increased the load on the webhooks component, and we reached 2K RPS. But this is not the end. So one day, a Katy Perry day happened. Katy Perry is a famous American singer who has a lot of fans around the world. Just imagine how many subscribers she could have back then on Facebook. And one day, marketers of Katy Perry decided to create a bot and chose Manychat to build it and made a post to subscribe to it. And just in a single moment that day, the peak load increased 4 times. Well, the huge and the massive load to the system that was not ready to it. And at this point, it really became obvious that to keep this sustainable growth in the future, we really have to implement a proper solution with queues, just to have more control over scalability and introduce loose coupling of different components. And we chose Rails as our key solution. Well, throughout the years, it proved to be an excellent strategic decision for the company. We've managed to leverage not only the simplicity and power of Redis and implement like the cascade queue system, which I'm going to be talking later, but also solve a bunch of different tasks like caching, locking, monitoring, and etc. Right now, our Redis cluster handles more than 1 million requests per second, which is kind of huge. And in our first solution, We replaced synchronous message processing, which happened between Webhook controller PHP and then the Webhook processor with a key solution. By this, we kind of made different parts of the system more independent and individually scalable. And since we increased the Webhook inbound capacity, we needed to add multiple workers to process messages out of the queue. However, this solution had its challenges. Well, the message queue could contain messages from different customers, while at the same time, on the other hand, it could contain sequential messages from one customer. For example, hello, followed by how you doing. And if the PHP daemon that handles hello slows down, and it's kind of handling its message slower than the one that handles how you doing, it would mean that our bot would respond in the reverse order. And this was a significant flaw in the system. While it might seem like, okay, this is an edge case that we could live with, that we could tolerate, at our scale, it happened pretty frequently, and we definitely had to do something with this. And Redis again came to our rescue. So we chose an approach where each bot gets its own dedicated queue. This way, only one process at a single moment in time handles one particular bot. But to be able to efficiently use computational resources without spawning one daemon per each bot, we implemented a control queue, which is kind of named with bots on the slide on the top. So when a new subscriber message arrives, right now our system publishes two messages to the queue. So the first one goes to the control queue, which is named bot, and which kind of signalizes that there is a bot that has something to be processed. Another message with the actual payload of the webhook goes directly to the bot's queue, which is kind of bot 2 would be. And then, when a daemon kind of is free to process something, he reaches out to the bot's queue, pulls out some message out of it, identifies what should be the bot to be actually processed, and then kind of assigns it to the specific queue of this bot. And this solution not only resolved our initial problem, but also eliminated noisy neighbor issue. What I mean by that? When a business suddenly experiences a spike in traffic and all their customers start communicating with the bot, it kind of no longer blocks the common channel, and other bots don't have to wait until this particular bot will be processed, in the entire case. And in this new approach, each bot has a dedicated processor, and the activity of celebrity neighbor no longer kind of affects the latency and the response times. And this approach also scales easily. So when we see that the control queue is filling up, we can dynamically adjust new workers to process messages. All right, by early 2018, our audience had grown several times, and we reached the milestone of 1 billion messages sent per month that are powered by Manychat. The average load of the system was 5K RPS, and this is not actually counting the spikes in traffic, it's just an average load. And we are still happy with Redis, it serves well, but at 5K RPS, PHPSrbija was no longer able to handle the load effectively. Again, we started searching for a solution. We researched the market and identified the growing popularity of the asynchronous processing and found React-PHP. React-PHP is an asynchronous framework, event-driven PHP framework that is designed to enable non-blocking I/O operations. So we conducted quick tests and eventually replaced PHPSrbija with React-PHP without any specific refactoring introduced to our processing part. So even though React-PHP was running alongside with our YE application, the solution still increased our throughput by 4 times. Initially, we started with 4 React-PHP services and eventually scaled up to 30. And for quite some time, this became our primary solution for scaling and handling the incoming load. However, as soon as we expanded the incoming funnel, like a lot of webhooks that we could accept right now, the bottleneck appeared on the processing side over here. Specifically, we began experiencing load issues on the data layer. And what did we do with that? To balance the load more effectively, we just took, well, actually we divided the processing part into clusters. We took all pods that we have and evenly distributed them among a certain number of clusters. This led to the creation of the so-called galaxy. So here's one galaxy, here's another one galaxy. But what is it? A galaxy is kind of both a physical and logical partitioning of processing. Each galaxy contains a certain number of clusters. This one is one cluster, this one is another. And from technical perspective, a galaxy consists of one single Postgres database server, one Redis instance, and one our application instance. So from the database standpoint, a cluster has physical scope and sense. So each cluster has a dedicated database that stores all its data. And Galactic RDS just holds all its cluster DBs. From the Redis perspective, every Galactic has a Redis instance that kind of stores all the data structures and all the views that are connected to the clusters. There are no physical boundaries inside the Redis space to separate clusters data, so we could say that the clusters are scoped in a logical way. So in a nutshell, every pod right now, it belongs to the certain cluster. And React PHP on its side knew to which particular cluster it should propagate the message, like the webhook for a particular pod. The rest of the webhook processing just remained the same. And this approach demonstrated actually an excellent load resilience. So we quickly realized that galaxies were our key to gradual system scaling. And as the Manychat universe expanded through time, we just could keep adding more and more galaxies to it. Nowadays we have 6 galaxies with around 10 clusters in each. Alright, next milestone, 2018. The number of subscribers reached 200 million. It made it difficult to estimate the SaaS platform on the scale, but to put the scale into perspective, just imagine that you have a website with 200 million active users. That's kind of a lot. And webhook in general is a relatively simple task unit, and to be honest, PHP is not the best tool to handle that. Even React PHP struggled to handle this inbound 10K RPS load, experiencing some memory leaks and others. But in the meantime of evolution, we continually transferred certain parts of business logic from React PHP to the actual processing. And one day we just realized that the only task that React PHP was doing is just routing the message to a particular queue, and that's it. And again, we started to look for a solution to it. And we discovered an open REST, which is an Nginx distribution. By default, it offered low language support and also included library to directly connect to Redis. Sounds actually like a perfect fit to our design. The first Nginx configuration example was written, let's say, in 3 hours, and it already proved the viability of this solution. Everything that React PHP with 30 instances of it was doing could now be implemented just in 50 lines of code. And I will show the example on the next slide. And this is actually how the architecture was transformed. So Nginx right now, it's responsibility to push the message to one of the inbound Redis queues directly. And then inbound PHP processor with some pre-validations propagates it next to one of the galaxy or to the statistics system that is now like a very sophisticated system in the bottom. With this solution, we again continue to handle the load effectively and focus on the business growth and new features. Yeah, and here's an example, I hope that it's visible to you, of an Nginx config file and just an injection of Lua script into it. So we'll start, we retrieve the request body in the first line, then we'll kind of calculate the hash and identify the cluster for the one of the inbound queues. Then we establish the connection to Redis, and then we simply push this message of the webhook to this particular queue that we identified. This is all what React PHP was doing at that moment. Now it's done just in 50 lines of code. The next major milestone came in 2019. The number of bots exceeded 1 million, and now the subscriber base reaching 500 million actually. We continue to enhance our load-based solution, and here we may see, like in the comparison to the scheme that was shown previously, right now it's an Nginx responsibility to correctly distribute the message to the corresponding queue. So right now, Nginx with Lua identifies whether it's a webhook with a message that should be processed in one of the galaxies, or it is a statistical one that we could simply propagate to the statistics queue. And I really like this slide. Just from the very beginning, it was a simple PHP plus Nginx plus webhook controller file. And right now, it may still appear kind of simple and easy to follow scheme, but at the same time, it is a complex system right now with distinct units that kind of operate independently and enable us to scale it independently also. And of course, each of the components is kind of sophisticated enough to deserve a separate technical topic and talk on that, but maybe in the next meetups we will highlight something out of it. So, 2020 to the present. And you might ask what happened. Like, the load previously was 25K, now it's just like 10K. That year in 2020, Meta introduced the 24 hours window. What does it mean? Previously, businesses could interact with the subscribers like for weeks. Right now, like from that very moment, this communication is limited to 24 hours. If subscriber doesn't interact with the bot, press the button to write some messages, like out of this window, there is no longer any ability to reactivate, send one more message, and engage them back to the communication. This kind of significantly reduced the depth of the communication and eventually the amount of webhooks that we have. And we also began working on pricing tiers. We kind of changed some of the features that are pro features, which actually reduced the number of free accounts and eliminated their sophisticated patterns, load patterns. And in the previous story, I was talking about how we scaled the inbound raw webhook processing. And we actually did a great job with that. Even now, years later, like we have a capacity to scale. So even now, if we experience like 25K RPS, our solution already could handle that, which is great. But since 2020, we've entered a new era, I would say, of business logic optimization. Just as we started to connect new channels, Instagram, WhatsApp, and TikTok, we enabled opportunity for various and numerous number of external integrations with the third parties for our clients. We also started to work on AI features and build the educational community, the community around Manychat, and provide the education on how to build sophisticated marketing chains. All of this just changed the focus from the incoming webhook processing more to the business logic optimization, that the patterns that users create, they are now more sophisticated and we need to kind of process them effectively. And I haven't touched yet the processing part, and as I said, it kind of could take hours to describe it in details, but just a brief overview of it. So there are several important aspects of processing that we need to address. The first one is dynamic management of workers. So when a single PHP daemon handles one subscriber and encounters heavy business logic or external requests or something like that, it cannot process the next subscriber. It just basically means that we would need an army of PHP daemons to be able to handle this load. However, we want to still feed into our kind of infra budgets, and we would like to spawn as many processes as needed at any given moment, just to avoid wasting computational resources. Load balancing across clusters. So the load in different clusters may vary over time. Just remember the Katy Perry case. And we would like to be able to redirect workers between clusters when a surge of payload occurs in one of them. External requests. With the introduction of a lot of third-party integrations and AI, we know how we now have a lot of external requests and we want to reuse computational resources, well, we kind of wait for the response from the third party. And different priorities for tasks. We also would like to have an ability to prioritize one single task over another by its kind of importance and latency tolerance. So welcome so-called handyman. This is an interface of one of the galaxies that we have and the changes of the handyman, which starts over here. Handyman is kind of our own payload agnostic task manager. Each galaxy has a handyman instance, and it consists of its own host process that actually controls the spawning of workers, telemetry service, and the workers itself. Each workers over here, they identify the specific tier and what the tier means. So the tiers, they give us the possibility to have different SLOs on the latency. So for example, tier 1 over here could be used for heavy and noisy payloads, while the tier 1 could be used for real-time sensitive specific tasks that we kind of would like to keep the latency under the single-digit milliseconds. And tier 2 over here is a special mode of handyman that enables us to do async I/O operations with leverage of promises. So the jobs in this tier that we use, they are able to serialize their state, and once the external request is fulfilled, they kind of resume the business logic of the processing from that state. And the worker manager host processes just observes the current state of the systems and could dynamically adjust the number of workers or redirect them from one cluster to another if there is a surge of payload. And it's kind of tailored to our system architecture to the possible extreme and leverages our empirical knowledge on the load patterns that we have at Manychat. And again, this is just a brief overview of the component. Maybe in the next meetup we'll talk about this one in more details. So let's finally take an overview on our evolution. 10 RPS, it was simple Nginx plus PHP FPM. Then we introduced Postgres queues to separate webhooks into different streams. Then we implemented Redis a cascade queue system at 2K RPS. Then our solution was React, PHP, and introduction of clusters and eventually galaxies. The next stage is 25K RPS and the solution that leverages Nginx plus Lua. And finally, kind of a switch of focus to the more product development and introduction of our internal tool, so-called handyman. Well, in system architecture, like is in life, evolution beats revolution. So we take one well-paced step at a time. And every challenge that we faced was an opportunity for Manychat to improve, and every improvement was a step towards a more resilient system. And I would say that from our experience, we have concluded that architecture can be built consistently, modifying step by step, and improving those parts of the system that are most vulnerable at this moment and that are actually the bottleneck of the system at the moment. And at the same time, we could use simple, well-known approaches without actually expanding the tech stack, the existing one. And I would like to end with this quote. So the function of good software is to make the complex appear to be simple. I believe we're kind of trying to do that. Thank you.
Now it's time for your questions. Please raise your hand and show out your questions. And I'm asking you to read the questions a little bit. Complicated, yeah. Go ahead.
My question is, which tools do you use for performance monitoring and latency monitoring?
The question is about what we use to monitor the latency and the actual monitoring of the system. I would say that we have a bunch of tools, but the major one that we use is the CloudWatch that comes in the Amazon Web Services. So we kind of have a lot of different ticks and a lot of different dimensions that help us to set alarms for different SLOs that we have in different parts of the system and react to them like in a single, let's say, minute if something goes wrong.
Lots of information, but anything you're curious about. We also have some prizes for good questions. Yeah.
Why did you use Redis for queues and not like Kafka or something else? Did you face addiction of cache or something like this?
Yeah, the question is about why did we use Redis instead of Kafka or maybe Revit or something like that, the other tools for the queues, which is actually a good question. And I have like multiple answers to it, please bear with me. So the first one, at this very moment when we were looking for the solution, the Kafka wasn't kind of that great that it is right now. So in 2018, we kind of conducted some tests on the load patterns, and since it uses the disk, not the in-memory storage, it kind of struggled to handle the load effectively at this moment. The second one, I would say that we have the luxurious opportunity at Manychat to follow the at most once principle. So we are kind of a little bit tolerant to some losses in data. That's why we can leverage the power of in-memory storage in comparison to the persistent one. The third thing is that we have the rule that we try to keep the length of our queues around 0. So the policy is kind of process the message once it gets there. So just in any hypothetical apocalyptic scenario that something happens in AWS and we'll lose all our data in Redis, it would mean that we would lose, I don't know, in 1 minute of data. And even from the user perspective, like if he clicks on a button or writes some messages, there is no kind of clear way what we should do like in an hour or in a 2 on the retry, so it kind of loses its value. And if we lost this 1 minute of interaction and then to reload, it's kind of okay for the user to press one more time on the button. That's it. But I believe right now, like Redis and Kafka could be different options if you consider the solution for the queues. I hope it was clear enough. Just I expected a large screen when I can show you a lot of images, but now it's a small one, and I tried my best. I hope it was clear. So any other questions that you have? Go on.
Do you use managed Redis or host Redis by yourself?
Could you repeat, please?
Do you use managed Redis provided by AWS or host Redis by yourself?
Well, let's say I'm not the part of the infra team, and this is actually a good question, and we could talk about it a little bit later, just because we have Anton with us from Manychat, who would definitely know the answer. But I would say that as far as I can judge, it is an Amazon managed Redis, so we don't have like a specific.
I'm asking because lately the Redis was moved from the open source to the closed source, and big companies like AWS and other providers have to pay for licenses there.
Well, that's a sad story. Like, it would be nice to have a lot of useful tools, yeah, in the open source. Yeah, it kind of affected, of course. So, and the entire system of Manychat, it's kind of dependent on Redis. It wouldn't be hard to kind of switch to another one. So, if this is the case that we need to pay, we would reconsider, of course. Yet, it costs, but considering the power and the simplicity that we get out of it, yeah, that's still a great tool. But it's a sad story that we need to pay for the software. I would rather vote for the open source. Yeah.
Did you have any other sites like PHPSrbija or something? And if they influence your architecture
Okay, I got you. So the question is about whether we had any other spikes in traffic and how did it influence the architecture. Well, the short answer, yes. We have them like in very unexpected moments, like in the middle of the night when somebody in Brazil does something. Yeah, there could be a lot of traffic. I would say that an interesting story is that one moment Nike company, it decided to integrate with Manychat and create a bot. And at this moment, I believe we were already in the kind of Nginx plus Lua solution that offered us a great support of the incoming law. And since I was not the part of Manychat at this time, but how I see it, I believe that the folks were kind of brewing some coffee and just chilling and looking at the load parents, and they just, okay, yeah, our solution can handle this, and that's great. So we still have the capacity to scale and to be able to handle any spikes of the traffic right now. But let's see what will happen next.
What about the other integrations such as TikTok? I think those should be different webhooks, so maybe not as much flow, but you still have to like link the users between those, right? How do you treat those? Would that be like a line in the Lua script that does or something like that?
1, 2, 3. The question is about TikTok. How do we handle the webhooks from this company and whether we treat them differently? Well, of course, they have their own API, they have their own format of the data, and they send the webhooks to a specific kind of endpoint and something like this. From the Lua side, there are no specific changes needed, just because the only and the simple task that it does, it just redirects to a particular queue. So it's like the first firewall, let's say, that just propagates it to the correct queue. But yeah, you're right, they have different load patterns. Right now, TikTok integration is still kind of in process. We don't have a lot of accounts over there, but TikTok is kind of a pretty popular platform. Someday it may be even more than Meta, who knows? But the redirection and the actual processing, it just happens on the next steps of the funnel. So the only thing that Nginx does, it just quickly puts the message, the incoming message to a queue. It could be a specific queue for the TikTok, for Facebook, for Instagram, something like that, with different workers assigned to it and the number and the balances and all of that.
Do you still use your PHP in mode? And if you use the PHP in mode, could you tell more? How do you configure your PHP in soft load? Which specific models do you use? Maybe specific settings or something else?
So the question is about how do we configure PHP workers, right? Is there any specific type of configuration, something like this, for the high load? That's actually an interesting one, which made me think for a bit. I would rather reach out to the Ace of Spades in my deck and say that let's discuss it a little bit later with the folks from the team.
Okay, let's choose.
Well, I actually like the type of question why Redis, not Revit and not Kafka. So this is going to be the one. Thank you all. Hope you enjoyed, and looking forward to enjoy the next topic.